Hi, this is Purnima Mahalingam, and you're watching video lecture series on power system protection switchgears. In last class, we have seen about the directional relay, and today in this class, we are going to discuss about the non-directional relay. Come, let's go into the video. Here comes first is an empathy. Why the non-directional relay is needed? Why the power system protection is critical? There's so many things is it there. One is main is the threat landscape and the human cost. The threat landscape is a power system constantly face threats from short circuits, overloaded, and equipment failures and fault current and can surge thousands of amperes within a milliseconds, create the extreme damages without robust protections and the transformer, the transmission line, and generators, which suffers catastrophic damages. So we have facing so many damages. And the next is the human cost, where the beyond equipment fault risk human safety is main important thing and causes costly outages, which affects the entire community and which effectively protect isolate only the fault sessions, which minimize distributions to the bordered grid. Here come the curious hint. That is, a single unprotected fault can causes millions in damages with the milliseconds. So that is the main thing why the entire power system is need to be protected. Now coming to why the non-directional relay is needed. What is the core principle and primary applications and based on mechanical designs, and we have an adjustable parameters. So trip based on solely on the current magnetic compensative, which ignores the direction of the fault current flow. Here coming to the commonly which is developed in radial distributed systems with single power sources, and we have a mechanical design contact an aluminum disc rotation between the electromagnet when current exceeds the pickup value, threshold value. Here, adjustable parameter, the time delay via with the time multiplier setting. The time delay, we have seen the inverse time delay and current pickup setting by CT and primary settings, which here comes the inverse time characteristics for large current. Here comes the principles of principle and operations. We have a definite time overcurrent relay, and we have an instantaneous overcurrent relay. We have inverse definite time relay, and we have a trip after a fixed delay once the current exceeds the pickup threshold value, which provide constant predictable operating regardless of fault surveys, and where a trip immediately when the current exceeds the pickup value with no interaction delay, which is idea for serve fault recurring, which is rapid solutions. Here come the operating time decreases when the fault current increases, the most versatile type of balancing the speed and selective effectively. Here the time current characteristics curve, which is defined relay operations parameters. That is, relay sets must be carefully balanced and selectively to prevent trips, which ensures adequate protections. Where IDMT relay protect distributions feeds by tripping faster for serve fault while coordinating with downstreams, etc. Here comes to the non-directional relay works in the practice like current measurements, and we have a disk movements and tripping initialization and time coordination. Here the relay configuration to trip at about 150% at greater load with 0.5 seconds time, which is delay, which provides both selective and coordination systems. Here comes the coordination problems. Here it is. The problem coordinations ensures the relay costly to fault, which trip and isolate only the affecting the backup relay, and however non-direction relay can't distinguish fault direction. They may trip properly for downstreams. The time gradient discriminations between the primary and the backup operations, that is 0.2 seconds. The primary relay A trip for a nearby fault, and 0.8 seconds, which is the final backup at sustainable levels, and 0.5 seconds backup relay B trip if the relay A failures. Okay. Now coming to the non-direction relay. Now coming to the non-direction relay, we have an radial distribution feeders, equipment protections, and earth fault protections, and backup protections, and cost effectiveness. Okay, these are non-direction relay applications. And now coming to the summarize, we have why the protection is needed, what are the fault deductions, and relay operations, and the relay types, and coordinations, and applications, and modern evaluations, and outcomes. What are the outcomes of fast fault isolation, which is maintains system stability and safety and power quality. This is the main thing. What is the outcome? Final outcome is the power quality. I hope you understood this non-directional relay, and we'll meet in next class. Thank you so much.